All right, so we're going to round out these last two sections before the exam, talking about the substitution method of integration. And this is really gonna allow us to find the antiderivative or to integrate much more complicated things. Up to this point, we've always been at the mercy of being able to manipulate it so that we could add one and divide, or we had some simple trig in there. But now we're going to be able to do a lot more. I also want to point out that if anybody's planning on going into Calc 2, integration is a big part of that. So you really want to take the time now to get a good foundation built and hopefully be successful then as well. So the first example that I have up here, you can see that there's really not a way for me to manipulate this so I can add one and divide like I have in the past. And you can also probably see that since it's a more complicated function, that chances are that it was built by a composition. And anytime we talk composition, especially when we talk derivatives up to this point, we know that a chain rule would need to be involved. And so what we're doing here is essentially undoing a chain rule. And so let me get through this first one and we'll circle back and take a closer look at what we did. So since I can't simply add one and divide, I can't manipulate, I'm going to let u be my substitution, and I'm going to pick the inside part of this function, okay, the inside part. Now, I can't just come over here and say this is 1 over u to the 7th dx. The reason is, remember, that x matches up with whatever we're integrating with respect to here. So if I want this to be a u here, I have to make this a du. So in other words, I need to change my dx into something with u's. Okay? Now, fortunately, we can do this. We've done this in the past when we studied differentials. If that's u, then my du would equal a 3 dx. Okay, that's just our basic differential idea from earlier in the course. And then if I want dx all by itself, I can just divide by 3. And now this dx right here can be replaced entirely with a 1/3 du. So I'll come down here. Again, this would be incorrect. Instead, I would need a 1 over u to the 7th times 1/3 du. Okay, now we're ready to integrate. We know constants can come outside of integrals, and I would rewrite this as u to the -7th du. When I write this as u to the -7th, I can add 1 and divide. So this would be 1/3 times a -1/6 u to the -6th. Since it's an indefinite integral, I would need a plus c. And my final answer then would take us back into x's. If we start in x's, we need to end in x's. So -1 over 18. Our u value was 3x plus 10 raised to the -6 plus c. So this would be our answer to the indefinite integral we started with. Now, remember, we've done this in the past, and I'm not going to do it every time now, but I do think it's important for this particular problem, maybe a few others. If I take this now and I find its derivative, it should give me this right here. So let me run through and do that real quick. So notice, to take the derivative of this, it would need to be a chain rule. I would multiply this down, I'd keep the inside the same, I would subtract 1, then I would go back times the derivative of the inside. So as I multiply the -6 down, keep the inside the same, subtract 1, derivative of the inside would be 3. So out front, this guy right here would give us a positive 1/3. A positive 1/3 times 3 would just give us a 1. And then this 3x plus 10 to the -7th, we could obviously flip underneath like I have it written here. So this actually simplifies perfectly, as it should, right into what we ended up with, or what we started with in the original problem. So you can always check your answers on these types of things by taking the derivative and making sure it matches up. Okay, so for our next one, it's kind of similar. We would start it in the sense of, can you manipulate it so that you can add 1 and divide? Unfortunately, not in this case. So now we're starting to think, okay, is there a substitution that can be made? Was this thing created by a composition, by a chain rule that we need to undo? And so, yes, we're going to let u equal the inside, and then our du would equal -2 dx. And if I wanted to get my dx all by itself, I would have a -1/2 du equals dx. So now I'll come over here to the side. I've got an integral 4th root of u followed by a -1/2 times du. Okay, so follow me here. I replaced that guy with all of that, and then of course this part here was my u substitution. All right, so now that's going to be a -1/2 out in front, a u to the 1/4 du. And when I come through now and I integrate, when I add 1, that's going to be 5/4, and divide, that's going to be times 4/5. And once again, indefinite integral, you still need the plus c. We'll go ahead and finish this off by simplifying. Out in front, we'll have a -2/5. Our u is 3 minus 2x, still raised to the 5/4, plus c. So there would be our final answer. And on this particular problem, I think it's probably a good idea to go ahead and check it as well, just to make sure that everybody's on the same page. So I've got my -2/5, multiply the 5/4 down, keep the inside the same, subtract 1, back times the derivative of the inside. And if I clean that front part up, that's going to give us a -1/2. And with that -2 off the back end, these do away with one another, and it leaves us with the 4th root of the 3 minus 2x as we should have gotten. So again, another good opportunity to just remind you that a derivative and antiderivative are opposites of one another, and we can always check our answers to most of these problems in the same regard. All right, so on to the next. We've got, it looks like a rational function here where again, it's going to be difficult to manipulate so that we can simply add 1 and divide. And so what you'll learn to realize very quickly is sometimes picking the u sub is a little bit of kind of trying to see into the future. Not only are you going to try to pick a u sub so that it allows you then to more easily manipulate, but it's also got to encompass everything else that needs to be accounted for. And so what I mean by that is this. If we let our u equal x squared plus 4x plus 3, that's great, but I still have the x plus 2 and the dx off to the side that I have to account for. Fortunately, though, when I take du, which gives me a 2x plus 4 dx, I still have some stuff there to play with. If I take the 2 and factor it out, and then divide off that 2, notice now with what we have left. This x squared dx, that whole thing, is nothing more than a 1/2 du. So the x plus 2 dx right here is now being substituted in with an equivalent 1/2 du. So as I write that now, I'm going to have a 1 over u to the 3rd and then a 1/2 du. So unlike the last couple where we just dealt with constants, now having an additional part of the function as our substitution is actually going to be quite helpful. So now when I go ahead and evaluate, I went ahead and pulled the constant out. At this point now you can call that u to the -3rd, and when we add 1 and divide, that's going to be multiplied by a -1/2 u to the -2nd plus c. So we get for our final answer then -1/4 x squared plus 4x plus 3 to the -2nd plus c. So just like the last couple, I would now encourage you to pause the video, take the derivative of this thing to confirm in fact it is this thing here, as well as you're getting that additional x plus 2 on top. So it's a really good one for you guys. Just again, pause the video, double check that, and make sure that's what you're getting by the chain rule.